Okay, so this problem is a booger. You can see it's question 16. I'm sorry, chapter 16, question 139, and it's a challenging one. So let me just start. Let me start from the top. I'm reading this along, and I see. All right, so I'm going to be adding some potassium chromate to a solution containing silver nitrate and barium nitrate. Okay. All right. And it looks like I'm going to get a precipitate. And the precipitate is this, okay? All right, but then it tells me, all right, so I've got a KSP. Let me change colors here. KSP, let me go with red. KSP of silver chromate. I'm going to write this as that. It's KSP, but I want to keep them separate. It's 1.1 times 10 to the minus 12. And the KSP of the barium precipitate is 1.2 times 10 to the minus 10. All right, so what's this mean? Well, this means that the silver chromate is substantially less soluble. Okay, so what that means is that my first few chromates that go in there, anything that precipitates out is going to be first of all silver, right? Because this is substantially much less soluble. Okay. All right. So let me think about this for a second. What's going on is we've got in solution. Let's think about this in terms of time. So I've got my chromate concentration in this solution, right? And what does it begin at? What's the when I'm starting this story out? How much chromate do I have in the solution? Right? When I ask a question like that, please consider pausing the video and thinking about it. All right, so let me suppose you've done that. You've got some kind of a guess. It starts out at 0, right? Because I'm putting potassium chromate in, but in the beginning, all I've got is silver and barium, and of course the nitrates. All right, so as I'm adding this in, what's happening? Well, the K of silver is equal to the concentration of silver. Oops, that's just silver 1. Squared times the concentration of chromate, right? That is that's the point at which we will get a precipitate. But when this is 0, we don't have any precipitate at all, right? So as we're adding this, at some point we get a precipitate. What is that point? Okay, so I'm going to call that point, this is the first concentration at which we get a precipitate. Let me go here, and this is at this point we get a silver chromate precipitate. Not all of it, but some of it, right? That's the minimum. So what point is that? Well, we'll figure that out in a second. Let's keep mapping this out. So as we go along, now the silver is being precipitated, right? I'm adding more and more and more. This is, let me go back here again. This is the first unit of silver precipitate. That's where we get the first unit of it, right? Anything less than that is not going to precipitate silver. Anything over here, not going to precipitate silver. Okay, so while we're coming along here, then we're precipitating silver. Okay? At some point, the concentration gets high enough to precipitate barium. Okay? So let's go with a different color. Can you read that? At this point, first unit of barium chromate precipitates. Okay? So what is that point? All right, so we're going to solve this problem separately. A couple different things here. All right, so let me come over here and move this down here and say, what is x2? x2, let me call this the KSP for barium, all right? This is equal to the concentration of barium, that's 2 plus, which we see we've got right here, times the concentration of chromate, right, when you get that first unit of barium chromate out, right? So we know what this is, and we know what this is. Okay, go meet with James tomorrow at Culver's in Buford. That's great. All right, so we know what these two are. It's this is x2. x2, you do concentration of barium over K. x2 is equal to K over concentration of barium. Okay, pause the video at this point and fill in those numbers and calculate it. Okay, let me suppose that you did that. This is K of the barium, so it's 1.2 times 10 to the minus 10 over the concentration of barium, which is 0.2. Agreed? And I don't have that calculated yet, but I'm about to. I should pause it myself, perhaps. (1.2) times 10 to the minus 10 divided by 0.2 equals 6 times 10 to the negative 10. Okay. Running out of room here. 6 times 10 to the minus 10. Can you read my writing? Okay. That's the concentration at which we get our first crystal of barium, all right? So this is equal to 6.0 times 10 to the minus 10. All right. So if that's the case, I think we've got to ask ourselves now, how much silver do we have in there? All right. So we know that silver was precipitating all along here, but it had a constant. Silver was precipitating with chromate, but all along here it had a constant ratio of silver and chromate in there, right? And that constant ratio is right. Okay. So as chromate was increasing from x1 to x2, silver was decreasing, and that's really the question. What is the silver concentration when we're done? Okay. So we now know that this. I'm going to go to a different page here. I should have probably done that before. Let me come to a different page and say that KAG is equal to silver squared times chromate. Okay, and it turns out this is the point when this chromate gets so big that the barium starts to precipitate. That's the question. That's how much silver we have left in there. Okay, so what we're going to say, this is now x2. Right? That's not when silver begins. It's when barium begins. Okay. So x2 then is going to equal to K over AG oops. Yeah. We're not really trying to solve for x2. We already know what x2 is, right? Now we're trying to solve for AG. So instead what we need to do for silver, what we need to do is we need to say K AG over x2 is equal to the concentration of silver squared, which is exactly what we were trying to figure out before. Let me disappear this and open that one up. That was what the question. What is the silver concentration when barium chromate just starts to precipitate? So let's go back over here, and it looks like the concentration of silver is going to be equal to the square root, going a little too fast here, starting to get messy, x2. Okay? Alright, now please pause the video and fill in those numbers, calculate it, and see what number you get. Okay, let me suppose you paused it. I'm going to put the numbers in here now. KAG, the KSP for silver, was 1.1 times 10 to the negative 2. 1 times 10 to the negative 12, I think. Let me go back and look at that. I think I read that wrong. Yeah, 1.1 times 10 to the negative 12. And x2 was 6 times 10 to the negative, what? 10. That's a 10. Is equal to, put that in your calculators, please, and calculate it. Okay, I get 4.28 times 10 to the minus 2. All right.